Shall I start then?
Wait,
We'll just
I
wait
try
for a
to,
couple more.
yeah, just give me a time,
Yeah.
moment to confirm. Uh, uh,
Okay.
Professor Rashid Ali, uh, sir, are you there?
Yes, I'm.
Okay, let's start. Renuga, please introduce him.
Okay. Very good afternoon to one and all. Myself, Dr. Renuka from Geetam University, Visakhapatnam. I'm privileged today afternoon to introduce our resource person, Professor Rashid Ali Garu, for the session 3 on artificial neural networks. Professor Rashid Ali is currently working as a professor in computer engineering in the Department of Computer Engineering, Aligarh Muslim University. Uh, he has many credentials to his vast, rich experience of 20 years of teaching. Some of his credentials are his recipient of prestigious Visvesvaraya Young Faculty Research Fellowship of Ministry of Electronics and Information Technology, Government of India, TAIF University Research Excellence Award by TAIF University, Kingdom of Saudi Arabia. He's a senior member of IEEE USA and also a lifetime member of Computer Society of India and IETE India. With his rich 20 years of teaching experience, he has supervised more than 20 MTech dissertations and 6 PhD theses. He also edited a book published by a reputed international publisher, Springer, on applications of soft computing for the web. Professor Rashid Ali is currently serving on editorial board of many reputed international journals and also a reviewer board of journals of international repute such as Elsevier Science and also on the Springer. He also received outstanding contribution towards reviewing by the Elsevier Science journals. He has authored more than 140, he presented more than 140 papers in various international conferences and authored many book chapters in various, published by various reputed publishers. He is also on board of many journals as reviewing and editorial, and his research interests include web searching, web mining, soft computing techniques, artificial neural networks, recommended systems, and online social network analysis. With a very little introduction to Professor Rashid Ali Garu, now I welcome Professor Rashid Ali Garu on the board to take the session on artificial neural networking. And I expect a very thought-provoking and value-added session to all the participants. Thank you for that, sir. So, Professor Rashid Ali Garu, please proceed.
Thank you, ma'am. Uh, I thank all committee members for inviting me to present something on artificial neural network. I'd like to share my slide. So I hope you are able to hear me. Yes?
Yes.
Okay, fine. Thank you. So today I am going to present something on artificial neural network, which we call in short ANN. So in this lecture, I will discuss something about the basics of artificial neural network, what are different application areas of artificial neural network, what are the learning algorithms for artificial neural network, and then summarize my discussion. So ANN is a biologically motivated approach to machine learning. What is machine learning? Machine learning is learning from examples. Now in today's world, we find data is everywhere. In business, especially, a lot of data is available in different forms, of course, sometimes raw data form, sometimes processed form, sometimes in databases. So how to learn something from that data? That is machine learning, which is a branch of artificial intelligence. And artificial intelligence is a branch of computer science. So let us start our discussion from intelligence. What do we mean by intelligence? This is he is intelligent, she is intelligent. What does this mean? Human being as such, we all are intelligent. We all are intelligent. Unlike computers, computers are not intelligent. Computers are not intelligent. Computers are learned. We make the computers learn. That means we as human beings, we are teaching computers to learn from examples. So artificial intelligence is that branch of computer science which is devoted to this field. How we can say utilize different techniques that are available in different domain to introduce some type of intelligence in machines. There is a very famous book, popular book I should say, by Russell and Norway, Artificial Intelligence, a Modern Approach. Because many people have introduced artificial intelligence in many ways. Some say it is to make machine intelligent. Some say we want to make machine act like human. Some say we want to make machine think like human. And depending on all these, say, different views and definitions, Russell and Norvig categorize all definitions, whatever has been given in this area of artificial intelligence. And of course, the development in all these areas has led to the development of artificial intelligence. So Russell and Norvig categorize all the definitions into 4 categories, where they say artificial intelligence means act like human. Then they categorize artificial intelligence definitions who discuss about think like human. Then they categorize other definitions that discuss about logical reasoning, that machine should say do something about say the reasoning process that should be logical. So in different ways, people have defined artificial intelligence. Now machine learning is the specific branch of artificial intelligence where we discuss about learning from examples. Learning from examples. That means we want to learn from data, because data is anywhere. You go to malls, you buy something. So data is being generated. Whenever I'm making a transaction, the online transaction or offline transaction, data is being generated. So how to utilize that data for the betterment of our life, for better services, for customer satisfaction, and many other things. So that is the area machine learning deals with. So machine learning deals with learning from examples, learning from data. And today we are going to discuss one specific techniques for machine learning that is called artificial neural network, which is a biologically motivated approach to machine learning. So we take an example. Suppose we want to diagnose disease from artificial neural network. We want to diagnose disease from using artificial neural network. So in a hospital, say there are patients are coming every day in a hospital, and the management is collecting data about every patient. What is, say, demographic data, what is the name, what is the gender, what is the age, and what is the address, phone number, etc. And also data about his health condition, what is temperature, what is blood pressure. Sometimes doctor says prescribe some test like RBC test, where they have count about WBC, RBC. Sometimes they ask the patient to go for, say, some checkup, some X-ray or CT scan, depending on the health conditions. Sometimes they ask the patient about the symptoms, whatever he or she is feeling. So all this adds to the database in the hospital. So patients are coming and the data is being generated, and the hospital has database of, say, thousands of patients. Now, how to utilize this data to diagnose a person, a new patient who is coming with some, say, problems, and doctor is seeing those symptoms. So depending on the experience, sometimes doctors suggest you can take this medicine. They prescribe medicines without further, say, investigation or checkups. And sometimes they advise them to go for some, say, tests, some checkups. This happens. So in, say, the intelligent systems, instead of, say, doctors' advice, doctors' expertise, what people want, they want to diagnose the disease depending on the data of other patients, historical data, the data that is already available in the database. So they want to diagnose the disease of a patient from the data that is available in database. And of course, there will be many parameters, what we call in our technical term features, or sometimes we call them, say, independent variables, like that in statistical analysis. So that is the thing. So data is available in databases, the records are there. Patient one data is also labeled. Data may be labeled, data may not be labeled. Suppose data is labeled that for patient one, there was the specific disease was not present. That means the patient one was not suffering from that disease. And suppose patient two was suffering from that disease. So that labeling is there, whether the disease is present or not in the patient. So this happens. So all this data is used to train the artificial neural network. So there is a system based on artificial neural network for disease diagnosis. So this system is used to diagnose the disease of a new patient. But before that, we need to train this system. We need to make the system learn, and system is trained system learns from the historical data of other patients that is already labeled. So this data is given to the system, and the system learns from it. Then a new patient comes, and new patient data is available. Whatever the features that were available in other patients, that is available also for new patient. But this labeling, whether the data in that is for portions, the specific patient's data, it was saying that the disease is absent, or it was saying, okay, no, disease is present. So depending on that, we have trained the system. System is now trained. So once the system is trained, we can use this system to predict the label for new patient data. That means whether the new patient is suffering from the disease or not. This information we can predict from the trained artificial neural network. Artificial neural network can tell us that, okay, this person is suffering from this disease. Or it can say that, no, this person is not suffering from the disease. But this happens only when this system has already been trained with the data of previous patients. So a typical architecture of artificial neural network looks like this. There are many layers of network. These circles, you can see, these are called some unit of this neural network, or we call in technical term neurons. So these circles, which are at, say, the first layer, that is called input layer, they receive the information from the database. Okay. Then in middle layer, that is called here hidden layer. Hidden layer may be one, maybe more, depending on the architecture of the neural network. We'll discuss in detail, if possible, later part of our discussion. And then there is output layer. So at this output layer, the decision is there, prediction is there. Okay. For example, it may be a binary, yes or no. So maybe 0 or 1 value. Yes, for yes we may have 1, for 0, for no we may have 0. So this is possibly here. So the number of inputs, that neuron that is we call here, that depends on our data. Some processing is done and some output is obtained. Now, what is the role of these, say, arrows, what we call these interconnections between different layers? These are very important. And these have some weights. You can see some connections are thinner, some are thicker. Okay. So that depends on their weight. And this weight is adjusted in learning process. We'll discuss in detail later on. So you can understand here that this looks like this. So we discussed this, that this neural network is, say, motivated from human nervous system. So this is a computational model that is inspired by the human brain. So this is, you can see, a type of biomimicry. We are trying to mimic the brain. We are trying to mimic the human neural system. We know brain is our CPU, what we call in computers, central processing unit. So brain is processing whatever signals are coming every time. And accordingly, the brain gives directions for actions. And that is why people, know that we are alive. Okay. I give an example. We are going by a road, for example. Say we are driving a car or we are riding a bicycle, whatsoever. Suddenly, we see that an accident has occurred, say few meters or few hundred meters ago before us. So what will be our decision? See, here we have perceived something from our eyes. Eyes are our sensors. So some input has come. Okay, we have sensed that okay, something is there, some accident is there, something abnormal is there. Then from our previous knowledge, our experience, we know that if we go at the same speed, we might also get some accident. So this, say, is our knowledge from experience that we have. So first thing is, say we have seen, then that is sensors. Eyes are our sensors. Our eyes are acting as sensors for the input. Now our brain works now and takes decision. What is the decision? The decision is that okay, we should slow down, we should apply brake. So decision is taken and we apply brake and save ourselves from the accident that might have occurred. So what is this? How much time it takes? See all the processing, how many things are involved here. We are sensing something through our eyes, we are seeing it. Now in our brain it comes that our knowledge, previous knowledge, that okay, if we go by the same speed, we also might get accident. Okay, so save ourselves. This is the decision. How? Apply brake. So brain gives the signal, and we apply brakes. So all this happens in few seconds or maybe microsecond, right? So how it is possible? It is possible through our nervous system, where we have, say, hundreds of billions of neurons, and they are connected, like we have just discussed in this figure. The connection between the neurons, and that is not so simpler, that is we are discussing artificial neural network. They are so complex. They are so complex, but they are at the same time they are much powerful, that in few seconds the proper decision is taken and we have saved many lives. So this happens. This is biomimicry, that people have tried to mimic it and made some computational model, some system that can act like human brain. So artificial neural network is a set of connected input or output units, where each connection has a weight associated with it. I told you that is due to weight. Some, say, arrows are thicker, some are thinner. If they are less weight, they are thinner. They are more weight, they are thicker. Okay. And this connection, they are very simple connection in this architecture, but some may be more complex connection. So they are connected. Input is there, output is there. But this at the circle, these are the simple processing element that we call neurons, the unit of this neural network. We talk of these neurons. So this simple processing element, but they are, say, large number and they are connected with each other. So there is a massive parallelism which allows for computational efficiency. Within few seconds, a lot of work can be done. So the synaptic connection among the neurons are used to store the acquired knowledge. And as I told you, the knowledge acquired by a network from the environment through a learning process. That is why when people start learning, maybe as a child, you can see yourself that learning is step by step. When child starts speaking, he does not speak, fluently. He speaks 1, 2 words, but slowly he speaks fluently. Similarly, when child starts walking, that's not in one day. It takes many days to walk like we walk. So all this, is possible due to the learning. And that learning is due to the complex neural system that is in our body. So artificial neural network learning is also called connectionist learning due to the connections between processing unit. That units are connected, and due to this connection, learning is occurring. So the intelligent behavior that we see is due to the large number of simple units. The units are very large in number, and there's number of interconnections. It's complex thing, and after this, we are getting something efficient. So this is just a comparison of human brain and artificial neural network. So what we find that the speed of human brain is in few milliseconds, but artificial neural network can have few nanoseconds, and because due to massive parallel processing, it's possible. Then if you talk of size and complexity, so in a human brain, we have 10 to the power 11 neurons that are doing 100 billions. Okay. And 10 to the power 15 interconnections. While in the case of NNN, it depends on the architecture. Depending on the architecture, this connection we will have. So the connection is not so complex, I should say, like in human brain. Human brain connection is, very complex in comparison to what we have in artificial neural network. If you talk of storage, the storage in information is done in brain in the interconnection in synapse we call. While in artificial network, the information is stored in contiguous memory locations. That one by one, RAM that we have in our system, laptop. Okay. So all these system, laptops. Oh, sorry. I think we missed something. I'm audible? Yes. Hello. No one is speaking. Ashok Mishra.
Ashok Mishra, can you mute yourself?
I'm audible? I'm audible?
Yes, sir.
Yes, you are audible.
Okay. So did I miss something when my voice was not clear?
No, sir.
Okay,
You didn't miss.
thank you. So I was discussing the storage capacity that in the our brain, the storage is in the interconnections, while in artificial network, the storage is in contiguous memory location. Okay. So in brain, there is no loss of memory until and unless there is some accident, what you call a head injury. So if there is head injury, then in that case, people lost memory. Otherwise, there is no chance of memory loss. But in the case of artificial network, loss of memory is always possible. Okay. Then if talk of tolerance, brain has fault tolerance. Some of, say, processing element, uh, if they fail, or some of interconnection they fail, that data cannot pass through them, information can pass through them. Even then, these connections are so too much that the fault would not, fault has occurred, but the system will tolerate it and the information will be passed. While in the case of NN, if some, say, in the architecture, some interconnection is broken, so there is information might be lost. If you talk of control mechanism, the control mechanism in brain is complicated. It involves chemicals in biological neurons. While it's simpler in artificial neural network. In case of artificial neural network, this is simpler. There's no so much complex chemicals or something that is involved in learning of artificial neural network. So if something about the history of this artificial neural network. So artificial neural network first appeared in 1940s as an analogy to a biological system that I was just discussing. And simple artificial neural network architecture were developed in 1960s, like we call perceptron, like we'll discuss. But suddenly in late 60s, I should say, some limitations of the simple and popular architecture were pointed out, and the research in this area was stopped. But again, in the 1980s, I should say late 1980s, about 1986, a powerful learning algorithm called backpropagation algorithm was developed, and this again boosted the popularity of NN. From 1986 and onwards, or you say late 90, say about 2000, I should say, even people, a lot of work has been done in this area of artificial neural network, and there are many applications of artificial neural network in diverse areas. So if you talk of application areas of artificial neural network in finance, in banking, in insurance, in all, we may find the applications of artificial neural network. For example, loan approval. In a bank, someone comes for asking for a loan. So what the manager will do, they have criteria whether the loan is to be given or not. So there are many parameters, and depending on that, they judge the applicants that whether the loan should be approved or not. So if, as I told in the case of disease diagnosis, if we have, say, history of loan applications, and we also have, say, the knowledge of the decision that loan was approved or not approved. For example, suppose there are two cases, either loan was approved or it was not approved, yes or no. So depending on those independent parameters of the applicants, for example, what was the name, its age, what was the salary, what was the the address, and many other things are involved. So depending on those parameters, the manager had decided something, and that is stored somewhere in database. Now we may use artificial neural network to decide whether the loan should be approved for a new customer. Suppose the new customer comes and asks for loan, we may decide. That means we may develop a system, neural network system, which may automatically decide that whether the loan should be approved or not. Yes, it's not so simple case. Suppose in a bank which is very popular, say thousands of applications are coming. Like again in the case of jobs, for in a company, thousands of applications are coming. So how to decide whether those applications should be accepted or rejected? So here the artificial neural network can be used. Similarly, in stock prediction, stock markets, the prices go up, prices go down. Today's price may go up or today's price may go down. So if we have the history of the stock prices of different companies for say last 6 months, last 1 year, last 2 years, then using artificial neural network, a system can be developed, and that system may automatically decide whether the stock prices will go up or the stock price will go down. Or even if we can develop a system on the historical data, we can predict approximate stock price. So stock price prediction can also be done. There's two things. Either the price goes up or price go down. That is the, you can say, trend. Or the second thing is that we can also predict the price value, that today is 60 or it will be 70 or it will be 100, like that. Similarly, the claim prediction for insurance companies. Yes, many times people make the false claims. So depending on the historical data, if say a number of claims are coming, thousands of claims are coming, and some decision has been made for historical data. So if somehow we can use that data and develop a system based on artificial neural network, then we can decide whether the claim should be given or not. So you see, the artificial neural network finds similar applications in many areas, like fraud detection, whether fraud has occurred or not. In sale prediction, whether what will be the sale, tomorrow sale, or like this. Customer profiling, in data mining for extraction of useful patterns for decision making. And I already discussed about the disease diagnosis and treatment, and sometimes also about speech recognition synthesis. So it's diverse areas of applications of artificial neural network. People have applied this in many different areas, okay, and successfully, I should say. And people are using it in many ways. So if you talk of properties of artificial neural network, why they are so much popular, that they are being applied in many areas. First thing is flexible input. There are other machine learning algorithms also, but the algorithms, they like you to provide your input in some specific form. Sometimes they ask for categorical data, sometimes they ask for, say, numerical values, okay. But in the case of artificial network, they can take any real values, and they are highly correlated or independent whatsoever. They can take any type of input. Moreover, there is flexibility also for target function, the output function. It may be discrete valued, like 1, 2, 3. Okay, it may be real valued, like 1.5, 1.6, like that also, or maybe vectors of discrete real values. Okay, so the outputs are real numbers between zeros and 1. Some values may be there. It's quite possible in the case of artificial neural network. And they're also, say, robust to errors in training data. That means even if there is some error in the training data, the data from which it is being trained, it has learned, if even there is some error, but it's so much powerful that it will go with that. Even with the error in the data, it will have good prediction. And prediction accuracy is generally high for artificial neural network. And we can also evaluate its performance very fast. But the criticism of it is that it takes long training time. Yes, the training time, is very long. Sometimes we call it epoch or iteration. So maybe thousands of iterations required when we can stop, training might stop. And the second thing is the learning function, how it learns. It learns from examples, learn from data, it learns from, say, connections, weights update, that's fine. But how it learns, how it is able to predict correctly, why its prediction accuracy is very high, it's very difficult for humans to interpret. So sometimes people say that neural network is a black box thing. You need not to think about any other thing. Just go. You have some input, you want some output, you train your network, then once the network is trained, provide your input and get the output, and forget how it has learned, okay, and why you are getting correct output like that. So this is the criticism of neural network. So when we should use artificial neural network, we should use artificial neural network for those problems where input is high dimensional, discrete, or raw valued. That means number of, say, parameters, the number of, you could say, independent variable that we call, or features we call, it is very high. Okay, hundreds of features are there, hundreds of parameters are there, hundreds of fields are there in your database. Okay, so if you go by, say, normal machine learning algorithm or statistical technique, maybe they may not be able to provide you the result in, say, reasonable amount of time. Okay, so it is advisable, if for such high dimensional, say, input, you should go for artificial neural network. When your output is discrete or real valued, you should go for artificial neural network. Output is a vector of values, or it's possible that output will have some noisy data, some error, and most importantly, the form of target function is unknown. Yes, we don't know what is the target function. We know that y is the output is a function of x, but what is f? What is the target function? We don't know. Okay, so if that is unknown, go for artificial network. It will learn f for you. Okay, and moreover, the human understandability of the result is not important. We want correct output only. We are not interested how I'm getting correct output. So if this is the case, we should go for artificial neural network. There are many examples, successful examples of application of artificial network, the problems in speech recognition, image classification, financial predictions, okay, where we are more interested in output. If output is correct, we don't want to waste our time how we have got this output. Okay, I give an example of speech recognition. Okay, in a room there are many people, and everyone is talking at the same time, and within the group there is one of your friends. So we as human are so much intelligent that we can recognize who is speaking, my friend is speaking or not, or even we can recognize sometime what is being spoken. Again, it is noisy, too much noise is there, but in those conditions also we have the capability that we can recognize. But if someone asks you how you have recognized, we don't know. We have learned it, but we don't know how we have learned it. From our younger days, we have started, say, recognizing people by their speech. Our mother, our father, like that. Who is our mother? Who is our father? We see them, and sometimes even we don't see them, just we hear their voice and we understand that father is coming, like that. So in all those problems, we can apply artificial neural network. Okay. So So if you talk of application of artificial neural network in business, I have given this reference here by Tech and Warner. They published a very good paper, research paper, I should say survey paper, in 2016 in one of the reputed journals by Elsevier. And there they categorize the different types of work done in the area of artificial neural network. Area of application is business, and what are different types or subtasks that people have taken to apply artificial neural network. So they categorized, about 14, 15 that is listed here in the slide, that in all these sub areas of business, people have applied artificial neural network. A lot of work has been done. They survey more than 400 papers. Okay. And on the basis of their study, they categorize that these are the areas or sub areas, I should say, where the NN have been applied. This is back in 2016. Now this is 2021. Maybe we don't know how much work has been done in the area of business, like accounting and auditing, cost monitoring, credit scoring, customer metrics, derivatives, financial distress and bankruptcy, decision support. Yes, decisions are very important. Any business cannot learn without, say, decision support. It cannot run without business support system, decision support system. The managers of different companies, they need to take decisions. So if there is some automatic, say, method, some system is ready to help in decision taking, then that helps a lot. And also about exchange and interest rates, financial analysis, fraud analysis, inflation, okay, marketing. Yes, very important, marketing. E-commerce websites, Amazon, Flipkart, they have applied machine learning neural network systems for recommender systems. They have developed recommender systems. That is why when we buy something, we start getting recommendation. People who have bought this have also bought this. How system knows? System knows from our historical data. System knows from historical data of customers, users who have the demographic data similar to ourselves, or in profile, their profile is similar to ourselves. So on the basis of that, the system starts giving recommendation. So artificial neural network has been successfully applied in marketing and also in sales and shares and bond. So a lot of applications of artificial neural network is in business. If anyone is interested, you can apply. A lot of research papers are available, and they can work on that. Now something about the artificial network. What are the basic building blocks of artificial neural network, and what are the important things one should know about artificial neural network so that they can use it in an efficient way. So first is interconnections. As we discussed, the interconnection, how the neurons are connected, how the processing elements are connected in a network, the way that makes the system powerful, and that decides about the capacity of the system. Then there are learning algorithms for the same type of interconnection. If we change the learning algorithms, okay, so we might get different, say, performance. So learning algorithms are also very important. There are various types of learning algorithms. So people can check with different learning algorithms and check for which we are getting better results. Then there are activation functions. Activation functions. We'll discuss what activation function because we have not discussed something, but you can say that something is another building block where we are, say, we call this exciting a neuron to predict the output. That is just before the final output. Just before the final output, we have some activation function. And when the input, I should say the net input goes through this activation function, we get some output. So there are different types of activation function. And if you change the activation function, the output will change. Okay. So which activation function should we use for our problem? This is to be decided. So we will discuss in detail one by one and each of these three. So if you talk of connectivity, we have different architectures of neural network depending on the connectivity of the neurons. One architecture is called feed-forward networks. You can see here that this is a layer, we call it a layer, that is input units, which is where we are receiving the input, the neural network is receiving the input. Okay. So you can see all connections are from input to another layer that is called hidden units, where the learning is actually taking place. Okay. So this connections, you can say direction of connection, the edge, this direction is always forward. That is what we call it feed forward. The input will come from here, go to this, okay, through these interconnections. Now it will add something here again, it will go to output. Again here you can see the direction is again forward. Okay, there is no backward direction in this architecture. So from input to hidden in forward direction, from hidden to output forward direction. The input is going in this way. And finally we have output. Okay. So this architecture is called the feed forward. First is called input layer, then we call the hidden layer, hidden may one, hidden may more than one, and then there is output unit, output layer. Okay. Next layer is recurrent networks, another prototype, another architecture of the neural network. So now here you can see this in this architecture there is some cycle. Yes, we want to call it cycle in technical terms. It that I'm going from one node, that one neuron, and I can again come back, that type of thing. For example, you can see here from going through this arrow I can reach here, and again by this arrow we can come back to my first place. So this type of architecture is called recurrent networks, and they have complicated dynamics. They are more complex than the feed forward. It's difficult to understand their working in comparison to feed forward. Okay, but at the same time biologically they are more realistic, they are more closer to the biological world, because I told you that in our neural system, human neuron system, you know, is more complex than our neural network in terms of, say, connections or neurons. Okay, so there are different topologies of this neural network. One we call single layer feed forward networks. Here just one input layer, one output layer. There is no hidden layer. Whatever is input is being projected into the output. Again, of course, there are many for one output layer node, we call it this neuron. There are, say, many input coming from many input nodes, right? And then something is done at this node, and then we get the final output. Okay, so there is no hidden layer. You can see this is called single layer feed forward networks. Input layer there, output layer there, but there is no hidden layer. Then there are multi-layer feed forward networks where we have one or more number of hidden layers. So it will be called 2-layer or 3-layer or 4-layer, depending on what is the number of hidden layers. If it is having one hidden layer, we call it two layer. If it is having two hidden layer, we call it three layer, because you can see there was no hidden layer, we call it single layer network. So if there is one hidden layer, it becomes two layer network. If there are two hidden layers, it becomes three layer network. Similarly, if there are four hidden layer, it will become five layer network, like that. Then there is recurrent network where we have feedback. Some of inputs are connected to some of its output, like that. So we have seen this. Now talk about learning algorithm. We have discussed the first block, that is called interconnections. Second is the learning algorithms. These learning algorithms are used for proper parameter adjustment, and that results in the production of desired response in reasonable amount of time. What does this mean? I told you that in each of these interconnections, there are some weights. Yes. And when it is trained, when the neural network is being trained, the weights value change. These parameters value change. Now, depending on the learning algorithms, the parameters value change. Some learning algorithms are so much powerful that they get the desired response, they train the network in less than amount of time. And they are so much robust that they can, say, go with error in input. So there are two types of learning. One is parameter learning, where we are connection weights are being updated. Okay. And second type of learning is structure learning. That means when we are going to make changes in network structure. What does this mean? This means that depending on training, we may like to change the number of, say, neurons at the hidden layer. Yes, here is 2. We may like the no 2. We will have 4, or we will have 3. Okay. Say input and output neurons. These will be fixed. Remember this. Input and output neurons, number of neurons in the input layer, number of these nodes in the input layer, number of neurons in the output layer, these will be fixed. This will depend, number of neurons in the input layer will depend on number of parameters, number of independent variables in your data, or number of features in your data. Suppose we have hundreds of fields, so the input layer will have 100 neurons. Suppose we have 200, so input neural layer will have 200 neurons. Okay, so depending on the database, depending on the data set, okay, whatever data we have for training, so depending on that, we will have these neurons at the input layer, and similarly the output layer is also fixed. Yes, the number of, say, nodes in the output layer is also fixed. For example, in this example we have taken 4. So this 4, maybe we have just 4 outputs. 4, maybe we have, say, 3, 2, 1, 0. 4 outputs are there. So we have 4. Or we may have, say, just 2. We may have just 2 output. Yes or no, just 2. So we may have 2 output nodes. So this design of this output layer will depend on the number of outputs. What are the different values of output function? Okay, we can have design like that, but we can always change the number of hidden layers. Okay, or number of hidden layers, or number of neurons in a hidden layer. For example, in this case there is 1 hidden layer. We may like that, okay, we'll have 2 hidden layers. This we can do. That is the change in structure. That is the change in structure. Okay, or we have just here 2 nodes. We will say, okay, now we have 5 nodes. So like that. So this change can be made, and then we can see the performance of the system, how the system is performing, whether it is able to predict correctly or it is not able to predict correctly. So that depends on, our data. Okay, depending on data, we can design the network that we can make changes in the structure. So what is training? The training is the process used to change the weights in the connection between neural networks to achieve the expected output. That I told you, that we are going to change the weights. We will assume initially all weights, say some simple values. Maybe initially we can say that, okay, all are 1, for example, all weights are 1. Okay, all connection weights are 1. Then later on we can change it. Later on we can change it. Yes, later on we can change it. So depending on the, say, process, what process we are using to change the weights in the connection between the network layers to achieve the expected output. What is the expected output? So that depends on types of learning. Okay, depending on, say, our data, we have to decide which type of learning it is. Yes, depending on our problem, depending on our application, we need to decide which type of learning it is, whether it is supervised learning or it is unsupervised learning, or we should go for reinforcement learning. So in all ways we can train our network, or we can go for the solving the problem using the artificial network. So we need to decide, and suppose we have labeled data. Okay, so we can go for supervised. That means the output is given for the data in the data set or database. We have to go for supervised learning. Okay, now if we find that, okay, we don't have output, so we will have to go for unsupervised. Or we want to improve the performance, we want to change the system at the same time and improve the performance depending on the feedback, what feedback we are getting. So we can go for reinforcement learning. So we'll discuss this in some details in next slides. So in the case of supervised learning, the learning is under supervision, like a teacher supervises his students or her students. Similarly, in supervised learning, learning is under supervision. So who is supervisor here? The data that is available in the database, available for training, that data will act as the supervisor. That is called labeled data set. The data set will be labeled. We know for every independent set of independent variable, the value of dependent variable. If this value is given for independent variable, what should be the value of dependent variable? We know that value is available. If these are the values of different features, what should be the output value of the output feature, like that. So we can build a model using the labeled data set. Okay, first we have to build the computational model using the labeled data set, and then we can use this model to predict the value of output for unlabeled data set. Just we discussed in the case of disease diagnosis that we had in training data that we have the labels whether the person is suffering from that specific disease or not, presence or absence. That is given for every patient whose data is available in the training set. So when we use this data, okay, and train the system, train the neural networks in the system, now when a new patient comes whose features are known, but we don't know whether the person is suffering from the disease or not. So the trained artificial neural network can be used to predict whether the person who has just come, new patient, he is suffering or she is suffering from that specific disease or not. So this example. This is for housing price prediction. Suppose a data set is given that contains n samples. So you can see this very simple data. Okay, some values of x is given and some y is given. Okay, for example, there is residence has x square feet. What would be price? Very simple data. So we have this data. We can plot this. Like price is there, square feet. This is given, and what is the price for every square feet, whatever that was available in the data set. Okay, for example, if for it is 15th sample, we'll have like this. Okay, that for 15th sample, this was the value of x, that is the square in square feet, and this is the value of y, that is the price. We know, and we have plotted it. Okay, now we want to predict what will the value of output, that is price, when x is equal to 800 square feet. How we can get it? Okay, because it's possible that in our training data set, we don't have the value of y for x is equal to 800. Actually, 800 will like here at this place. We don't have any value for y here. You can see that is not present. So we need to predict it. So what we can go do, we will say have some model. We can say have a line, okay, as the model, and where this our say line in this line, suppose there's some line from this x equal to 800 where it touches this line, this yellow line. So that point will the value of the y, that is the price that we can get. But we can have like this also, maybe a curve also. So whatever this we want to fit this function, whether it's linear or quadratic, to the data set. Okay. So suppose we want to have more features like this. Suppose we have size as well as the lot size. What the plot set, what you say. So what would be the price? Okay. So we may have say many features, not only 2 or 3, maybe many features. But for a set of features, for one item or for one object, we have the price, the dependent variable value available. Okay. For every item in the data set that is given, this price is available. So this is supervision, that whatever labeled data is given in terms of this y, this can be used to build a model, and that model can be used to predict the value for unknown sample, new sample. Okay. So this we can do. So maybe have high dimensional feature like living size, lot size, number, flow, conditions, zip code, many, that area wise. So what is the price? So you know the complexity of the problem is increasing. The problem is same. We want to predict the price of a house, but as we are increasing the number of parameters, the complexity is increasing. Earlier it was just one dimension, and second dimension was the output. Now then it was two features, so it was 3-dimension problem. Now this dimension is increasing. Okay. So if this output is a continuous variable, like we are predicting the price, it's called regression, you know well. And when it is to be categorized, a category is there, or some discrete value there, 0 or 1, yes or no, like that. Okay, or maybe sometimes multiple classes are there. Okay, so in that case, this will be a problem of classification. So both this we can learn and these both of the two are supervised learning problems. Okay, so this is an example that these are one class, that is house, other is that is townhouse. So these two classes are there. Okay, so some new data comes, okay, new sample comes, whether it is a house or it is a townhouse, we have to decide which class it belongs to the say house class or become townhouse class. So this is problem of classification. Okay, so we can have some line that distinguishes one class from other, or some function that distinguishes one class from the other. Okay, so prediction, we are predicting some say continuous values like price of a car or price of a stock or price of the house, depending on the attributes. We call it a regression. And when we are going to decide about some categories or discrete or where, like we call it a classification. Like for example, credit scoring, or I was saying about say loan approval, like that. So we can say low risk customer or high risk customers, depending on the values of say income or savings. So we may have some rules that income is more than this and saving is more than this, then it is a low risk customer, otherwise it is high risk customer. So these two classes, this low risk and this high risk, which is denoted by this say plus or minus. Okay, that for this maybe loan should be approved, for this loan should not be approved, like that. So if this is the case, so this line, you can see this line and this line together, okay, they are distinguishing the low risk class to high risk class. And from this we are getting this rule that this, if income is more than this and saving is more than this, then this low risk class, otherwise it is high risk class for this area. Okay, so this is the problem of classification. So depending on the feature, here we have just two features, savings and income. We have just two parameters, savings and income, two say variables, savings and income. We are predicting the class, whether it is high class, high risk customer, or it is low risk customer. So these classes are two here, binary classification. We call it binary classification. There are only two classes. Now another type of learning is unsupervised learning. Unsupervised learning sees what happens, what is happening, or discussing about what is stand inside the data. Okay, so in this case of learning, unsupervised learning, there is no output. The data is unlabeled. Okay, the data is unlabeled. We have no output, right? For example, we have a task of clustering. We want to cluster the customer depending on their say their profile. For example, we want to say the customers who are says who may purchase a lot of items in a given month, and customers who cannot say buy at all, and customers who have say little chance of buying this. So we can group them in different group of customers, and depending on that we can have targeted advertising. Okay, the customers who are likely to buy the product, so the advertisements will be given to them, and the customers who are unlikely to buy the product, the advertisements should not be provided to them, like that. Okay, so other applications also in the case of summarization or association analysis, that we want to summarize something, or we want to find association, that if this is there, for example, a person who is coming to say supermarket and he's buying say bread and butter, it's likely that the customer might buy also milk. So this is the association, that if there is bread, there is butter, there is a chance that the customer also buy milk. So this is called market basket analysis. This is possible by analyzing what people are buying in a supermarket. So we have a database in the supermarket, and from that database we can perform this association analysis, which items are being bought by the customers together. Okay, and that may help to increase the revenue, okay, to increase the sale as well and profit as well. So in many applications are there. Okay, so one example I just given, customer segmentation in customer relationship management. So these all are examples of unsupervised learning. So in unsupervised learning, there is no feedback, there is no labeling, there's no output. Okay, so the neural network itself discover patterns, regularities, features for the input data over the output. Okay, input is only given, and from that input, it should say design something. It should say combine something and provide the output for the new thing. Okay, so for this, while we are doing this, the network might change the parameters. The parameters will change. So sometimes we call this process self-organizing. Self-organizing. That network is changing its structure or its like thing parameters for say learning by that. Okay, this unsupervised type of learning. Then there is reinforcement learning. In the case of reinforcement learning, some network is there. Okay, for example, suppose there is train network, and for train network, it is predicting some output. Okay, then suppose for that output, we also have say the desired output. Okay, so we compute the error. What is the error signal? And then there is some reinforcement signal. What change should be made? That is the feedback. Feedback is given. Okay, that okay, this if you make this type of change, then the performance might improve. So this is combined, and that is given as the net error signals. And finally, the neural network learns, and we get the final output. So when we should use reinforcement learning? So reinforcement learning is used when less information available about the target output values. We don't know much about the target output. Okay, so we should go for reinforcement learning. This is very much popular nowadays when we are talking of robotics. Robotics, we talk of this reinforcement learning, or even in the game playing. Okay, to improve the performance by every say day. Okay, reinforcement learning is used, and this is the learning based on the critic information, and the feedback sense is called reinforcement signal. And the feedback is just evaluative, not instructive. Just defined. Okay, this message, just like in a game, you get a score that if you hit this target, you will get plus 100 or plus 200, and if you miss the target, you will get say no reward, or it will be say minus sometimes. So if that is the case, that is the case of reinforcement learning, that by having this reward or punishment, we are trying to make the system learn, and system should come up with the better performance. And you need see that happens, that after a few days, system plays well like that. So there are many popular learning algorithms under these different categories. For example, under supervised learning algorithm categories, we have Adeline and Madeline for this neural network. And this is all for regression, where we are predicting the continuous values. Then we have perceptron, one of the initial learning algorithm to train the neural network. And then I told you in the late 80s, the back propagation was developed, and this back propagation algorithm is very much popular supervised learning algorithm, at least for multi-layer feed-forward network, what we call multi-layer perceptron. Multi-layer perceptron is a multi-layer feed-forward network. So this MLP back propagation is very much popular. Okay, I will discuss if time permits what is the back propagation, how it works. Okay, then there is a radial basis function network also they use, where we have just exactly only one hidden layer. In multi-layer net perceptron, we may have one hidden layer or more than one hidden layer, But in radial basis function networks, we have just one hidden layer. Then there is unsupervised learning algorithm for neural network. One is called competitive learning. Competitive learning, where we call winner takes all strategy. That who is the winner neuron, it will take care of all the neighboring nodes. Okay, so by this the system learns on its own without any labeled data set. Okay, so the Cohen and self-organizing map, this was the architecture that used this competitive learning, and very much powerful. And then there is Hebbian learning, which is the again biomimicry, I should say, of the learning of human being. Okay, that is feed forward unsupervised learning. So this Hebbian learning is the real neural learning in our body also. What we are learning is Hebbian learning. Okay, where this synapses, they change size and strength with experience. So whenever two connecting neurons are firing at the same time, the strength of the synapse between them increases. So in this is the linear Hebbian learning. So neurons that fire together, wire together like this. And the learning approach that based on the adaptation in Bernoulli system is perceptron. I just told you in 1950s, developed 1950s, very early days, and the more complex was developed in the late 80s. Okay, that back propagation network. So this was all about the learning algorithm. So we have discussed, say, about the interconnections, and we discussed that due to change in interconnection, we have different types of neural network. Then we discuss about something about the learning algorithms. What are different types of learning algorithms? Supervised, unsupervised, reinforcement. Okay. Then we have activation function. This is very important. Okay, and it is used to calculate the output response. I told this the output layer. Okay, whatever the output we are getting, that depends on the activation function that we have used at the output layer. In fact, whenever we use neural network, in a single neuron also we have the activation function, and depending on the activation function, this output comes out from that neuron. Okay, so the sum of the weighted input signal is applied with an activation to obtain the response. So the activation function can be linear or non-linear, like it can be identity function. What is input? That is output, like that. Y is equal to X. What is the output? Output is same as the input. So there's the identity function, or single or binary step function, or it might be discrete or continuous sigmoidal function. So there are many types of activation functions. The list is some of the actually popular activation functions are listed here. Okay, so in case of identity function, it is fx is equal to x, y is equal to x. That is for all x, what is the input? That is same is the output. Then there is a binary step function that if the x is more than some threshold, we call this theta here, and then its value is 1, otherwise value is 0. Then we have a bipolar step function that if this x is more than the theta, it is 1, otherwise it is -1. So this is called bipolar. This is binary, this is called bipolar. Then the sigmoidal function is continuous function. Or we have ramp functions also, that if x is greater than 1, it is 1. If it is between 0 and 1, it is x, or if it is less than 0, it is 0. So there are many other activation functions as well. So this was all about the building blocks of the artificial neural network, that interconnections, learning algorithms, and activation functions. Now we are going to discuss some important terminology of artificial neural network, like weights, bias, threshold, learning rate, momentum factor. So as I told in the beginning itself, that each neuron is connected to every other neuron by means of direct links. And the links have weights. The links have weights. There are some weights in the links. Okay. And these weights contain information about the input signal and may be represented as a matrix. Okay. What about, say, is coming input? So that input will be multiplied with the weight, and that will come at the net input to from that previous layer to the given neuron. Okay, and weight versus something called connection matrix. So bias is also like a weight, but it's included like a component other than the node in the input layer. So suppose there are four variables or four input nodes. So bias maybe you can consider as the fifth one, like that. So bias may be of two types. One with the positive bias that increase the net output, or it may be negative bias that decrease the net input, like that. So bias is also added. Then this threshold, that this is a value on basis of which we have the final output. Okay, and this is used in activation function. We have seen every activation we have some talk the theta, that threshold. Okay, that if the value net input value is more than the theta, it should 1. If it's less than theta, it is -1. That in the bipolar activation function. Then another concept is about learning rate. This learning is denoted by something called alpha, and this is used to control the amount of weight adjustment at each step of training. As we discussed, that whenever training is going on, the weight is adjusted. What is the initial weight? Initially we may have all 1, but as the system is trained, so after training, different interconnections will have different weights. In a trained neural network, the weights on different connections will be different. Okay, so how much say we should change in every step, because it is training is in different steps, and this is one of the criticism of say neural network, that they take too much time, a number of iterations for training. Okay. So as they are taking time, okay, and number of iterations for training, so how much it should change? Because if you make say faster convergence, you want the output converge to the desired output quickly. So you need to change the learning rate. Okay, so the learning rate is taken some value between 0 and 1, maybe 0.05 or 0.5 or maybe 0.3, like that. People take this. Okay. Then there is a momentum factor that is added, and this helps to converge. Okay, in the weight updation process, a portion of the weights is again added as this. So whatever change has occurred, if you make a portion of that again being added, okay, with this momentum factor, so this helps in faster convergence. So this is a typical example of a single neuron, or you can say perceptron. Okay, so you can see here that this input vector, okay, we have n-dimensional input vector. We suppose we have just say n-dimensional input vector from 1 to n, and suppose we take this 0 as the bias. Okay, similarly we have the weight vector, that is the connections have weights. So we consider that there is number of weights are same. So there is weight vectors, and this is the summation. This is being summed, and then something is added here. Okay, and then some activation function is applied, and this activation function, depending on this, we get the output. So this is the simple typical architecture. So this was the early neuron. This is the basic unit in every neural network, and it acts as a linear separator. This acts as a linear separator. Okay, so we can see that here we have n inputs, 1 to n, and for every input we have some weights, w1 to wn. So every input is multiplied with this. For example, w1 multiplied with x1, w2 will apply with x2, and wn will apply with x10, like that. And a bias is also added. Okay, that is the constant, some constant. This is not an input because its n dimension input is there. So bias is added, that is some constant, and it's associated W0, for example. Okay, so that is added. So finally we will have a weighted sum of inputs, okay, like that. So output, before this output, we will have this net sum, net input I should say. So net input will look like this. Now we will have some threshold function, okay, or activation function, that some threshold is defined, and if the value of this output is, say, more than this threshold, okay, is more than the threshold, its output is 1, or if the value of output is this net input is less than the threshold, then the output is -1. The output is -1. Okay, so for learning the artificial network, okay, how this learning happens, what is happening here. So this, you can see the model is there. So we have input nodes, we have output node, and the weights are there. Okay, but this is a black box how the learning is going on. But what is happening, the output node sums of each of the input value according to the weights and compare this output against some threshold. Okay, what about the threshold? This net sum with the threshold, and if its value is more than that threshold, that means it's given value, say 1, or it is less than that, it's given value 0 or -1, like that. So this is the perceptron learning. So if we are going to train this neural network, that we have to initialize the weights first, then adjust the weights such that the output is consistent with class levels of training examples. That means, what is the meaning of this? Meaning of this is, what was our output, okay, for given say weight and given input variable, what was our input vector and weight vector, what was our output, yi. Okay, this yi, this is available for training data. For training data, we know what is the value of dependent variable. So we'll match the prediction. The prediction will be matched, or you should be compared with the actual in the value in the data set, and the error will be computed. And for every example, this error will be, say, squared and then summed up. Okay, so depending on that, this is the error. Okay, now this error is to be minimized. Yes, because this error is error in prediction. This error is error in prediction. That if this error is more, that means our neural network is not predicting correctly. Our neural network is not predicting correctly. Okay, so we would like to minimize this error. And for this minimization, we have many algorithms. We call it gradient descent and backpropagation algorithm. There are many algorithms which say are used to minimize this error. So perceptron, that was the earlier neural network model, person learning model, that was acting as a linear separator. As long as the discriminant, the class, the separator is linear, okay, then they can clearly distinguish one class from the other. Okay, so if it is, this is like a line in a two-dimensional space, or it may be a hyperplane in an n-dimensional space. So as long as this is linear, okay, they can very efficiently distinguish one class from the other. Their performance is very good. Okay, but if they are the items or objects in different classes, they are not linearly separable, we can use a network of them. Then this perceptron will not work. Okay, so for example, perceptron cannot learn exclusive OR function or parity function in general. I hope all of you know these simple things. Maybe some thing in your high school, or maybe at inter, this logic and or not or XOR. This is some function, some logical function we call it, that for 1 what should be value, for 0 1 what should be value, like that. Okay, so system obviously cannot learn some concept, it cannot present. So this Minsky and Papert, they were the authors in 1969. They wrote a book where they analyzed the performance of perceptron and demonstrated many functions which could not be learned by this perceptron. And this result discouraged the further research on neural network. So if you consider this perceptron as a hill climbing, this objective is to minimize classification error on the training set. So perceptron effectively does this hill climbing, that is gradient descent in this space, and this changes the weights of a small amount at each point to decrease training set error. And for a single model neuron, we may get some single minima. Okay, that is the least error point, and that works well. Okay, so for linear threshold function, perceptron performance is very good. Okay, but it converts fairly quickly for linear step data, and it can even use incomplete common results. Okay, even some outliers are present. So perceptron does quite well for many data sets. This is very good, performance is very good, but as well as long as the data set is linear, the output is linear, the classifier is linear. Okay, like this is another say, and we call this caret sign, and we call this OR, we call this XOR. So if you see this linear separability, this is AND function, that for this values is 0, for this it is 1 1, like this. So we can have this OR function, or this OR function, but this we can have a linear function here. Okay, the linearly separable data is there. Here again linearly separate data is there. Okay, but what to do here? One class is this side, this here, and this, no, this is not linearly, so this will fail here. Okay, so what is the solution? The solution is to use multi-layer network. Instead of one perceptron, one neuron, go for a layer of networks. Okay, increase the number of layers. Okay, that means add some hidden layer. Okay, so a typical multi-layer network will use some input layer and output layer, and between that one or more hidden layer. Okay, and the weight will determine the function and computed. So it is claimed that in this multi-layer network, the hill climbing is very good. Okay, but if we do gradient descent, we want to change this say error. So the function, the activation function should be differentiable. Okay, so for multi-layer networks, we cannot just use linear network. Okay, we want some non-linear activation function. Okay, so instead of using linear activation function like this, we have discussed this binary bipolar activation functions, we have to use some non-linear activation function, and sigmoid function is one of them that is differentiable. We can differentiate this. Okay, so this is the differentiable output function. So if you use non-linear function, okay, so we can say distinguish one class from the other, because this is now differentiable. So this is some mathematical calculation, and this shows that this is all differentiable. So in gradient descent, we want to minimize the error, and for this error we want that the activation function should be differentiable. So if we can perform this differentiate, we will get output like this. The error will say output look like this, and we can compute that. Okay, and error will also look like this. So this back propagation algorithm, they use this method, and where they I should say collect the input and then compute the output, and in number of layers, one hidden layer and more hidden layer, and their weights are modified to minimize the mean squared error. That means the error between the actual output and the target output. Okay, so the modification that the errors, they are made in the backward direction. See, data moves in the forward direction, input moves in the forward direction. Okay, but the error, the difference between the actual output and the target output that was given in the training data set, that is coming through the hidden layers to the first layer, that input layer, in form of, say, backwards. So that is why the name is given back propagation. Okay, that is the name is given back propagation, because the input is moving forward, but the error is coming backward. So there are many steps of this back propagation algorithm. First, we initialize the weights to small random numbers and biases in the network. Then propagate the inputs forward by applying activation function. Then back propagate the error by updating weights and biases. And then terminate condition whether this error is very small or number of iteration has been applied or there is no change in the error, like that. So many things are there. So we may decide about a network topology, what should be the number of units, what should be the architecture, what should be the number of hidden layers. Okay, that means we need to design our network. For any problem, we must understand what is the number of input, say parameters into factors, what is the number of output, and then we should have to decide about the number of hidden layer, hidden nodes. And it is advisable that if you want better performance from your network, must normalize your data in some range. For example, 0 to 1. So every data, every value, that means whatever raw data is given to you for different parameters values, try to make the values of every parameter, every factor to come into 0 and 1. Okay, so one input will come for every domain value and each is initialized to 0. And output, it is if it is for classification, it will depend on number of classes. Okay, and suppose there are 2 classes, we'll use 2 output unit. If there is 3 classes, we'll use 3 output unit, like that. Okay, so once we find that network has already been trained and but their accuracy is not acceptable, then what we can change, we can repeat the training process, and by changing the network topology, we can change the number of neurons in input in the hidden layers, or we can change the number of hidden layers, or we can have a different set of initial weights. We can make these changes and then we can see what is the effect again. So by making this, we can have finally the list error, and we can use that trained network that is trained with finally very less error to predict for some final values. Okay, so neural network can do both supervised learning and unsupervised learning. Neural can do both regression and classification. Neural network has both statistical and artificial rules. So I think I can stop here, and now we can ask, because time is almost over, so I think some time should be given for question and answer session also. So if any question, you are welcome. Whatever I discussed today here, if you have any query, any question, you are most welcome to ask. Yes. Any question from the audience? No question. Okay, so Dr. Jamshed is there. Participant don't want to ask any question? It's like that? Yes?
Wait, ma'am. Wait, sir, for a minute.
Okay, so meanwhile, I would like to show you some list of books that you might be interested. Okay. So if you want to get more details,
Sir, can I proceed?
yes.
Hello.
Yes, let him share that.
Okay. Okay, sir. I'll wait.
So these are few books you may find useful for the concepts of neural networks. Okay. And for therefore references that you can see, this one of the author is Simon Hacking, and this has written books: Neural Network Comprehensive Foundation, Neural Network Learning Machines, and there's some Bishop book also. So these are good books for neural network. And this is the paper that I was talking about for artificial neural network in business. Okay, 2 decades of research. Very good paper I found in a reputed journal, Applied Soft Computing by Xavier. So you can see some titles there about stock price prediction, okay, stock market also. And this is, if you are interested in other machine learning algorithms, you can go for this Michel book or for Russell Novy book at the difference. So, okay, now you want to ask any question? Yes, question was being asked, I think. Yes.
No, she is waiting for concluding the session. Actually, she is
Okay.
not asking questions.
Okay. So any question? So I think no one wants to ask anything. Huh? Either they could not understand anything like that, huh?
No, no, sir. It's not like that.
Okay.
It's not like that. It's an emerging area, na? So we are taking
Okay.
the insights.
Okay, good. So these were this few slides
Okay,
that
sir.
you want to say. Okay, thank you.
Yeah. Uh, uh, Professor Rashid, sir, very, very thankful to you. On behalf of all the participants, I would like to thank you for the great insights on this artificial neural networking. This is actually an emerging area in the management of in management research, especially in the area of our own area, finance and all. This is really emerging, and the insights we are getting is really useful to our further research. And exclusively for young researchers, the books and the resources you have shared are of really great help to us. So we wholeheartedly thank you, Professor Rashid, sir. Thank you very much, sir.
Thanks, sir. Thanks for giving quality time. Dear participant, for the tomorrow's session, we need someone from the audience to volunteer if for the second session, if someone is ready. If someone is ready, please contact us for the second session.